What is up, car and craft fans? Welcome to part 4 of the series where we make a custom Arduino powered brake light multifunction light thing to go in the spoiler of the back of my Nissan 350Z. In this part, we're going to touch on 3 things predominantly. First is just take a quick look at how I changed the circuitry from the prototyping stage through to the production stage, which it now is. Then we'll look at taking the things that I've used, the Arduino, the optocoupler, the step-down voltage regulators, all that stuff, and packaging it into a way that's going to be safe and easy to use in the car. And then finally, we'll 3D model and print a project box to hold it all together. So let's jump straight into this because it's going to be another relatively lengthy one. First up, let's take a look at what we've done so far, just to remind ourselves where we're at. If you recall, by end of part 2 of this series, we put together an Arduino Nano with a HM10 Bluetooth module and a couple of buttons that powered my NeoPixel strip matrix of lights. And we were able to go in with our mobile phone and change the colors and the settings and all that kind of stuff in there. We also had a couple of buttons that were able to control the glow state, the reversing light, and the brake light. The thing is about this setup, though, is that it's not ideal to put in the car, predominantly due to the fact that we're using an independent separate Bluetooth module, because it just means you have to add a load of extra either traces or wiring in there when connecting them all together in your final circuit board. The intention was always to change to one of those, and that's what we've done with this new chipset, the ESP-32. There are multiple versions of this chipset available. I've gone for one by a company called the Woroom ESP-32 chipset. Is basically exactly the same as a Nano, except instead of having the Bluetooth separate as a separate thing we're going to need to wire in, it's integrated in there. As you can see, that massively simplifies the amount of wiring and stuff that we need, and we can really reduce the complexity of the circuit down to basically just that individual chipset plus the inputs that come in from the buttons and whatever outputs we need. The thing is, though, because we've changed from a HM10 Bluetooth to this ESP-32 Bluetooth, the code's a bit different. But if I run through all the differences now between the two and all the updates, then this is going to be a 2-hour-long video that no one's going to watch. So I'll just save the code updates for another video, which I'll release at the same time. And if you want to see that, I'll have it linked above. Otherwise, for now, let's just take this prototyping board setup and go and wire it up properly for production standards in order to be able to put it into a car and have faith that it's not all going to fall apart and break. So let's go from here to the other work table and start building this thing properly. Location switched and on with the show. Let's take a little look at everything we're going to be using for this, because even though it's a small thing, there's quite a lot of stuff we're going to be using. Right, so we know our circuit. We've got our little light set up. We're not going to be doing anything with this for a while, so we can get rid of that now and just save ourselves some space. We've got our prototyping board, our optocoupler, which takes our 12-volt car signals and converts them to 5-volt input signals, our 12-volt to 5-volt module. Then looking around the outside, we've got a bunch of breadboards, proper ones for actually finishing a finished product. We've got this larger type, which has got trace tracks, which are already full lines across here. So if you put anything in one of those lines, it's available in the whole line, in the whole column, I guess. They're probably going to be pretty useful. And we've got these other ones that have got just individual points. These are a bit trickier to use if you're going to want traces and things connected up in lines. We'll get to that. We'll see what we're going to use. We've got some wire, obviously. This is rated up to 30 volts, but it specializes in being ideal for 5 to 15. Perfect. Wire cutters, some scissors, a variety of different pliers and snips, a Dremel tool with a Dremel metal cutting disc on it, some helping hands. Oh, a hand has fallen off. These are great for just like holding onto clipboards, or if you want to do things like soldering iron and solder, and obviously flux. We can't do it without flux. Insulation, thermal, like fabric tape stuff. This will be great at the end when we're taping up like the wires and things together. A multimeter, so we can test the circuit as we go. Got some paper here and a pen where I can make some notes, and a few little boxes of stuff. These are PCB terminals, so these are little things that we can pop in the boards that will allow us to insert wires into them. Will massively reduce the amount of soldering we need to do. And these little stand things, so these are basically tower block like building things that all screw together, which we can use like in the holes around the outside edge of here and start to build blocks that are interconnected. Probably going to use these, not 100% sure. Then heat shrinks in a variety of different like widths, just for holding wires together. And finally, I think these clips, these are waterproof car electrical connector clips. So we can do things like if I want to have 5 wires out, instead of having to go and then connect them in 4 different places, we can put the 4 in one and then the ones from the car in the other end, and then create like terminals. We'll just make our life way easier. I actually haven't used these ones before though, so it'd be interesting to see how we get on with them. So that's all the stuff that we're going to use. It's quite a lot for a simple project. So one thing to look at before we get into the rest of it is what changes I made to the pin orders and why. I thought originally I was going to end up with the data pins on one side and the power pins on the other. Not actually the case, due to the power source coming in via the optocoupler and the 12 to 5 volt module. So on this side we've got 5 volt here at the bottom, then ground is a few pins over, and then there's a bunch of data pins, and we were originally using 32, 25 and 27. What we've done though is shifted them all over 1 to 14, 26 and 33. The reason we've done that is that we want them every other pin, including the ground here. So they've all been shifted over 1 just to accommodate the ground. What that means is when we're using these PCB connection things, these are spaced every other pin. So they don't go in pins next to each other, they go into every other pin. And if we want to use one on one end connected to the ground, we then need to go every other pin from there. So ground, 14, 26 and 33 are every other pin, which means I can use one of these in my PCB. Then we'll have another one of these on the side for 5 volts, and all the data and the power for the Arduino will come out of one side. So when we're building our circuit, we need to start thinking about that and like the way all this is going to lay out. So all the data and pins coming out this side. So let's just pop that on there for now. Then we've got power coming out of this side. So we've got the optocoupler has 2 inputs that we're going to be using. Circuit 1 will be for the brake light. Circuit 2 is going to be for the disco lights, for the neons. And then another one that comes in for the 12 volt input on the 5 volt converter module. And then, yeah, we got power that comes out of that, will power the Arduino. Also power that comes out of this will go off to the lights. So the light stuff goes off here, data pin light stuff goes off here, all lights go this way, and all power stuff comes in here. One thing I'm trying to do is reduce the amount of soldering I have to do. I am not a fan of soldering. I'm not very good at it, so I try to reduce it. Otherwise, you might get to see a grown-ass man cry, and nobody wants that. So what I'm going to try and do to minimize my need to do that is use one of these trace lines as a common grounding circuit. So I can put, for example, one of these on lengthways, let's say just there, for example. Then I can have the one ground on here go out to the 12 volt of the car, then the other 3 connect to the 3 grounding points, so to optocoupler spot 1 and 2 and to the 12-volt circuit. So first up, I want to think about the size of this board, and I don't need it to be as long as it is. It basically only needs to be the size of my optocoupler. Also, I want to use these kind of mounting sticks to mount this board and this board like back to back, but far enough apart that wires and things and the connections on the back, there's no issues of them potentially touching and shorting out. So I want to size these two and then create some holes in this, which will allow me to use these. So that's going to be our starting point. I'm also going to leave this board a little bit wider, just to allow myself to have, like I said, that grounding trace along one of the sides. I can just cut this to size, so let's just use some 3D printer clips, which I use basically for everything. That's going to be the size, and sometimes if we're real lucky it'll just go in one. Oh no. Yeah, there we go. Dead easy. When we come to the very end and finishing this, I'll sand that down, but don't need to do it now. And then I want to make sure I can put these towers together, so I want to just make some marks where I'm going to drill everything through. So let's go one off center. Let's go there. Then this track is free up the side to be drilled. Yeah, there. But I need to consider this. Before I mark out the holes though, this actually needs to be flipped this way because we want the trace to be on the underside so that my Arduino is on the outside. That's actually going to be up against that edge. Like that. So let's just mark this thing out. Why is that so stumpy? Who's bugging my pen? Won't fit through, so I'm just eyeballing it. Okay. Assuming I mark those correctly, I should just be able to see all four of those holes through here. Yep. Great. We need to cut those holes out. We could use a drill, but I'm going to use the Dremel tool. Also, while I've got this end on the Dremel tool, I'm going to just cut a line that doesn't break everything. It doesn't break this in half, but we're going to cut down the middle to basically disconnect the two sides of this track. So it means I can have the wires, things on one side and things on the other side, and they don't interact. So watch your ears, this little bit is going to be a bit more noisy. Easy. So now you can see there's no copper that goes over that, which means these two sides are different. So that's our disconnect in the middle, and now we need to put these holes through, and I'm just going to use another attachment for the Dremel. These are engraving bits, but they should do the job, I would think. That, I believe, is all the noisy stuff out of the way, at least, so that's it. I'm going to need the optocoupler. I'm going to need to see these sizings for this plate holder, so we'll go for, needs to be basically the distance of that. Too big. Basically bang on. So these have just got like holes in them, and there's various kinds of screws and attachments. So 4 of these 4 small screws. Then pop it through the front. the back. And all being well, these four corners of this will line up and go through. Pillars, and it'll all slot together like that. So if you wanted to like create another layer and have multiple things like stacked, you could do that and then take more of these and then screw them together and continue to make layers. We're just going to have the one, so once we've finished creating all this, we'll just use the screws to put it back together and then create an external housing that fits all this and is custom sized. But yeah, that's how those little tower things work. They're pretty useful. So now we can start putting all this together and seeing where everything's going to be before we solder it, because we don't want to solder it as we go and figure out something doesn't work. So we'll put it in space and position everything and then solder everything at the same time. The Arduino is going to want to go on here somewhere like there. So the 5-volt circuit is at this end. It comes down. I just want to make sure this third row in is not interrupted by that hole, and it's not. So 1, 2, 3. That's great. And then none of the data pins and the ground pins are interrupted on this side. That one there, 23. Maybe this one here. I just want to make sure don't ground through this screw or something stupidly. So let's just cut, again, like we did the center track. Let's just cut this track above here, and it'll just above this screw, and it'll stop anything, I don't know, weird and accidental happening. Great. So the board's all ready. How are we going to set this up? Like I said, we've got these 4 pins on this side. So ground, 14, 26, 23, and they're all going to be used. So let's pop one of these on the end facing outwards. Make sure that's all lined up. So this one's going to have the ground. Then there's going to be 12, 27, 33, which I've actually done as 33 at this end is the data out for the lights. Then there's the 2 in, so the optocoupler for brakes and for neons next to that. Then we're going to want one on this end for the 5-volt in. The smallest one of these I have is a 2. It's not a problem. It just means the one that is here for data pin 3 just isn't going to be used. That can go there, though I think this might interfere with my top of my bolt. So I'm going to try and just shift it all one space this way. That doesn't go off the end, so that's fine. So I can just shift everything one down. And there and there. Then, like I said, I wanted to create a common point for the 12-volt negatives. That's going to be these tracks across this end. Let's go one from the end. Just make sure I don't go into a point that interferes with anything. I don't. That's good. They're facing inwards because I'm just going to do them off this edge. And yeah, so one of those will go out to the 12-volt of the car. Then 3 of the others will go to the optocoupler, 2 negatives here, and then the 5-volt modulator. So let's start by just soldering all these pins in the end. So we've got 4 pins here, 2 pins here, and 4 pins here that all need doing. Obviously the big trick is flux. If you don't know about flux, it basically uses magic to make solder stick. That's about as much as I know about flux, I'll be honest. So we're going to solder this pin here to start with. And we're obviously being really careful here not to get solder in between the traces. they're all soldered in place. I'll take it, I'll be honest. And then these 4 basically just need the whole row doing. Let's see. See, I got some over it there. Fortunately, because of the gap in the trace, it's not going to stick in that middle bit. Again, not perfect by any means, and like I said, I got some onto here, but there's a gap there, and we'll just check it with the multimeter in a second, just make sure that there's no signal connection between the two. But otherwise, I think we're probably okay. And it's a lot easier doing this process than it is having to like strip wires and then put wires across various parts of your board and solder things to the wire. At least with that's done now, so these are connected. And we can make sure all of our connections are working just before we unplug the soldering iron by putting it onto this. Checking, do we have connection here to here, which we should do. Yep. And then on the underside, we'll go from here, somewhere along that trace there, yep. 2, 3. Just, and then check the ones next to it, make sure we got nothing correct. 4. Good. Nothing. Now I just need to solder the board onto it too. So 5 volt, if 5 volt lines up with the 5 volt, there, then everything is okay. So none of this interacts with that or there. This is all clear. And these pins all line up with the ones they need to. So what I just need to do is solder on the ones on this side that have got corresponding things there. I'm actually going to use the helping hands for this, because if I just put that on the desk like I did before, the Arduino is going to fall down because it's not as deep as these. But with these I can grip like the whole thing, including the Arduino from both sides. Actually, let's do it from opposite corners, like that. Just okay. And then I can just get in here and solder these. Oh boy, I think we're going to make it. I'm just going to put solder on a couple of pins on this side, none in particular, just it'll help keep this end of the board down and stop anything from twisting and moving. They're all like not going to interact with anything, so it doesn't matter. And with that, hopefully, fingers crossed, that's the soldering done. I hate soldering. I can't get over how much I hate soldering, but I'll be honest, that went surprisingly well. So this now can get mounted to the back of here. Which way round do I want to do it? So this is over here, that way. Just by mounting it now means that because I'm putting the wires in next, I can just make sure I cut everything to nominal lengths. Use little screws, Should never over tighten these, else you'll just crack everything. Just finger tightening is fine. Great. So this is my circuit so far. Time to start connecting things up. I only have black and red colours of these, so I'm going to just use black for anything data related. So let's start by just connecting up the two really simple ones, which is the optocoupler out, so one here, just needs to go into the break, which is 26, that one, and then 2, which is the neons, which goes into 14 there. So these two middle ones. I can't find my little screwdriver anywhere, so I'm using a leather awl, which you use for stamping holes in leather for hand sewing. Sometimes it's just a case of needs must. Make sure these are open. So number 1 is optocoupler 1. There. Obviously a decent pair of wire strippers are going to save you a ton of time. I really like these ones, the standard ones. Nice and inexpensive, but really do the job. They'll be on the tools list in the description, along with the list for everything else. So this one is going to go into 26, right next to it there. And then this one to 27. Okay, I'm just trying to keep these lengths kind of as minimal as possible. That's that end in. That's our optocoupler data signals in to the Arduino. So this one here is the ground, we're not worrying about that one, and that one's going to go out to our lights. So this one we just want to make a longer data pin. We'll get to the actual length and everything of it later, but for now so that will go out to our lights. Then the bit we're going to be try and be quite clever with here is all the grounding pins. So one of these is going to go off, and then the other 3 are going to go, 2 of them into here, which is what we can start with, and then the third one going into the 12 volt, which again will attack when we get there. I'm going to make the endmost one here the one that goes off to the 12 volt of the car, and then the other 3 are the 3 that connect to the various spots down here. So just because again of the orientation, one will be on this side, that one will be on that side, and this is going to go to the 5 volt, which I just said I'm going to be putting over, which side is it, over this side. So I'm going to want, yeah, that over that side. So this, yeah, so we're going to have 12 volt module, opto 1, and then opto 2. And then one more, which is the one that will go off to the car. Actually the final, I think, of the 12 volt lines. This one is going to go off to the car, so we might want to reinforce that in some way. We'll get to that. This one's going to go off and over this way, which is going to go to the 5 volt, and then these 2 go into the optocoupler negatives. So it's the this one and this one respectively. Again, just keeping it relatively short. These ones don't really matter which way around they go because they're just grounds. But just by keeping things consistent and in line or order, we have to come and debug it at some time or take anything apart. It just makes our life a bit easier because we know where everything is. And then the two other ones, let's just forget about these for now because they're going elsewhere. Let's just finish off the octocoupler with two lines, two longish ones that come out and are going to go to the car. So they'll go into our harness. So slot 1. And slot 2. Now it's going to be important if we like splice these together to know which one is which. So we'll label them in a moment. So then on the other side, this one goes off to the lights. We still need the power and the ground, which we need to put out of here. No. We need the power and the ground, which needs to come out of the 12 volt. So it's now time to put the 12 volt in. Last piece of this like little puzzle. So the output over here, we'll start with that, is going to have two 5 volt outputs. 1, 2. One of them is going to go, no, one needs to be longer than that. One is going off to the lights, the long one. And then the short one is going to the power on the here. Oh, I also need one to power the board. So is that 3 outputs? Oh, I'm not sure if 3 of these twisted together is going to fit in here. Let's give it a go. Now that's not going to go in and me be happy about how securely that is in. So I've got one of two choices. I can either have these together and then solder them to a single line, or I can do another one of these. 1, 2, 3, 4. I mean, I've got to extend out that side anyway, but this one is interfering, so that one doesn't fit. I could do it over here, like there. And obviously I just need to cut that terminal there so it doesn't interact with this, but I could do that. It's not really on the right side of the board. So then this would need to wire to here. Oh, this is an oversight. You know what I really need to do is go out to the car and take some measurements of the spot that it's going to go in and see if I can build my tower a little higher vertically. I think that would give me the most robustness. So just go and take a measurement. Yep, okay, bags of space where I'm going to put it. Basically where the rear windscreen wiper motor used to be, because like most people with a 350Z, it's been deleted. So there's a big bit of space. So I can afford to go higher vertically on this thing. So that's what we're going to do. So we'll take another one of these long trace boards, and I'm going to want to go on this side. I've got a feeling if I put a thing that's full of metal on top of my Bluetooth receiver and encased it, it might act a bit like a Faraday cage and not actually get signal. So I'm going to put this on the other end, and then we'll just, like I said, put 2 of these couplers on here so I can put my 5 volt and my 5 volt ground circuits out. Yeah, that's good. What I'm going to need to do first though is cut this one to size. So let's do it with the magic spin. Booyah. Okay, so that's the size, and again, Let's put some holes in it in the same spots. Again, I want the trace facing inwards. So let's just add those holes. Great. And then the last thing we need to do is, extend these screws at this end into tower block stands. So we can just, these are going to be dead easy, just take off all 4 of these at one end and then replace them with sufficiently large blocks. Which one is it? Is it that one? No, bigger than that. Yeah, that size. So we'll do that for all 4 corners. And then when we've got this one wired up, we can pop that on top, connect those up together, or we could basically wait until we could put this on here, then put another layer of stands up that go through here and into here, and then in the 3D printed box that we create have holes at the bottom that can go through and then basically lock this onto it. I think that's probably going to be a nicer way of doing it. So we're not going to worry too much about connecting this to this like permanently, but what we will do is just tack it in place when we've done our prototype. So this is going to go in the middle, and this thing doesn't have holes in it, and I don't trust to drill through any part of it to put a hole in it. So we're just going to use some kind of adhesive and pop that in place, which will be fine. There's loads of ways of doing it. You can use like a blob of hot glue, or you could use double-sided adhesive tape. I'm just going to need to see what I've got because I'm not 100% sure. I have some 3M double-sided adhesive tape, so this will be perfect. Let's just pop it in the middle, actually just to the right of the middle. Yeah, there we go. Okay, so that's just going to stick to that. And then we're going to need to solder, which we maybe should have done first, but whatever, 2 different 4 gangs, because we've got 3 wires that go out and then they're circulated by 1. So much like we did last time, I'm just going to make sure there's nothing that it's going to interact with. And again, we'll come inwards because I think that's the sensible way to come. So this side's fine because that track isn't going to interact with anything. But on this other side, there's a chance that, again, like I showed you on the previous one, that this might, ground with this or something, I don't know. So I'm just going to put a little cut across both sides of this to prevent any grounding through the pillars. And then solder all of those just in place there. Just taking a coffee break whilst my soldering iron heats up. Are you able to follow this? Is this a process and a thing that you think is actually useful in like showing you how we build this stuff for cars? Let me know in the comments because I'd love to know if you think this kind of like really entry-level tutorial stuff has got some good value. Also, if you do enjoy it and you want to see a lot more, we have tons of stuff coming, so make sure you hit subscribe. Pro tip. I dare say I'm actually getting better at soldering. That was not horrible. Great. So we've got this board ready, and then that can attach onto here like so. Got nothing that interferes on the underside. That's great. So we just need to start wiring all this up. Just to make life a bit simpler as I do it, I'm going to just put 2 of these screws in opposite corners just to hold it all together temporarily. Actually, why bother? Why don't I just put the the stands in that it's going to use. There's one size smaller than that, but I think they might be too small. Yeah, that will hit. So I can put all 4 of these stands in. This will also mean, by having these as like the lowest point of contact, means that when this is put into the 3D printed thing, none of the circuit's going to hit the outside edge. Should just be good for making it a bit more robust. Okay. So yeah, that can sit like that, basically inside its little container with the Bluetooth on the top, and we'll put holes in the bottom that these screws can go through into here and basically hold it onto the 3D print with all the stuff around the side. But for now, we just need to finish up this wiring. We've got one wire here, which needs to go to the negative DC in the 12 volt. So that's this one. So that's negative. The opposite one, the 12 volt, just has a long wire which goes out to the car. So we can just pop that straight in. So I believe that's the 12 volt side of the circuit done. We need to stick some labels on here to make our lives a bit easier, but we've got the 12 volt that goes to the ACC switched power, the 2 that go to the optocoupler, and the ground circuit, which then distributes to the 3 grounds, 2 in the optocoupler, 1 in the 12 volt. Yep, so that side is all complete. Now we just need to do the distributions on this side. So we've got ground circuit here that needs to go, ground circuit here. No, ground circuit here. And one that goes out to the lights that all need to go into the ground there. So this needs to go from here. These 2 points need to go to my distributors here. So here and here. So 1 and then 2. And then these distributors can then distribute to the other stuff. So now we have our ground over here that goes to these 3. And then our live, well, that 5 volt circuit over here. So now these 3 want to come out this way and go into a couple of spots here, and then 1 straight out, and the same with this. And that, my friends, as chaotic as it looks, is it complete. Ta-da! 1 box ready to go. So let's just take a look at how the circuit goes, just to remind ourselves. So on the bottom, the side with the power block, which is going to sit at the bottom, we have a cable that comes in, a live that comes in, which will be the 12 volt power, which goes into our 12 volt module here. And we also have a ground that goes into this splitter, which then splits the ground to 3 spots. So it goes into the optocoupler in the middle for the brake light circuit, it goes into the optocoupler for the neon light circuit, and it goes down here into the 12 volt module. So those 2 do that. Then these 2 do the circuits for the actual lights themselves. So this one's going to get spliced eventually into the brake line, and this one into my neon line. So they all come out like one side together in a little bundle. On the other side, we have the negative for the lights, the power for the lights, and this one that I've marked with a little blue heat shrink as the data for the lights. So these will just get kind of like bundled together on each end, and there'll be holes in my 3D print which they come out the sides of, and that'll help. When we do that, we'll put something on them that will help, you know, stop them getting pulled. So that's going to be the next job, is taking this thing and creating a 3D model that we can just 3D print and slot this into, that then attaches to the car in some way. So here we are several days in the future, and the 3D printed box is all complete. But before we get into looking at this, we should probably take this whole mess of stuff and test it. So we're just going to take this thing out to the car and touch a bunch of these wires up to the battery whilst the lights are attached, wherever the lights are. Here they are. Whilst these are attached, and see if it does what it's supposed to do. Fingers crossed that we've got no problems. Let's head out to the car. Here we are out on the car, and I've crudely twisted the wires together to join up the light grid to the little bundle. And there are some little labels I've created just to put on here that say glow break and VCC, so I know which one's which. So all being well, if I connect the ground to the ground over here, I'm just going to pop it in there to kind of like hold it. There we go. If I take the VCC and connect it up, this should powers up red. Yeah, okay, it takes a second, but that's just the startup procedure. Great. So if I jam this again, just try not to make any of these twists untwist. If I jam that in there, great. And then if I peek through the sides of this, the optocoupler light here, might be difficult to see, is on, and the light on the 12 to 5 volt underneath is on, as you would expect, because they're all wired from the same point. The lights here are a little bit dim. Fortunately, that's an easy change in the code. We just changed that number. I hadn't seen them out in the daylight, so we're going to want to just increase that. But the big question is, do the glow and brake lights work? So what this should do is trigger that optocoupler circuit and change the input states to on and off in the ESP32. So let's start with brake, and hopefully we get a big red. There we go. Brake light. And then this one, I don't remember what colour it's currently at, but the glow light. Glow, so it's green. See, it flickers a bit when it changes. That's just because I'm not creating a great connection. That won't be a problem when we've actually wired the thing up. So if I also connect the glow light permanently, I'm going to use the word permanently loosely there, then this should overwrite with the brake light. Bam. Again, like I say, those flickers will be eliminated because of the way we're going to wire it. So this system all works, which is great news. So now I can take it inside and actually package it up properly and get it ready to install. Lovely. Now, because I know all this is working properly, I have confidence that I can put all this together and we can get it ready to install in the car. So let's take a look at the project box that I made. So we've got an outer box with 4 holes at the bottom, which actually line up with the holes of the bottom of the struts. There are a couple of print issues here where there's been some separation between the layers. It's pretty common if anybody knows about printing with ABS. It's a pain, but I'm not worried too much about that, and I can, when I'm done, just stick some kind of super glue in there and that'll just hold that. Then there's a lid face thing that I spilt some glue on, and a attachment base with a cutout in the bottom. So the idea is that this slots in here, and then we can screw the bottom pin things into these. Wires will come out this end. Then we can use this little latch in that hole. Pop this in here, which will close in the other end. And I've taken one of the leg things, one of these leg things, made a little insert there with another hole, so I can use one of the screws to just hold that shut, and those two things together will hold that shut. Then all of this mounts onto this base. So this base can go into the car and get attached to the car. I was considering screwing it, but we might just use adhesive strips, not sure yet. And then something can run through that. I've got a couple of options. and basically strap over the top and hold this down to the car and make sure nothing moves. So that's how this box works. If you would like a larger breakdown of how to create something like this in Fusion 360, let me know in the comments and I can do some videos about that, because I am a product designer, so this stuff is my forte. And let's get it all together. I'm going to have the bundle of wires for the power, this side, go through and come out this side. And you can see I've used a little label maker to make some of these. We use this label maker, the kata symbol, little wireless thing. You literally just have an app and you send the text you want to it from the app. It's actually really good. It'll be in the product list in the description. So yeah, we've got some labels on so that when I put all this together and these just random wires are sticking out of this end, I'm not lost with what's what. I'm going to start by just trying to get these all through the hole. Might just be a fiddly minute or two. That's all 4. Great. So it's all 4 through the hole. Make sure it's the right way around. And there is a channel basically missing down the side, which is why I was able to put that channel in with the hole. Just slowly feed it into position. Just trying to make sure the wires aren't getting like crushed or anything. And once these are lined up, these holes on the bottom are lined up with these pins, I should be able to just use some remainder of these. We use the short screws. So that goes through the bottom there and into that leg, just like that. And we should be able to just get all 4 just to line up like that. Okay, right, so that's all 4 of those. As we can see, it holds everything and gives about 1 millimeter around all the sides, which is just enough just to make sure this isn't going to move and then nothing's going to impact it from any of the sides. Then we've got wires out this end. And on the other end, like I say, I've installed one of these legs into a little custom-made hexagonal hole. I can just take these here. Pop that in that slot. And 1 more screw. There she is, ready. Sort of ready. We need to do one last thing, which is replace all these loose wires with these car connector clips. Now, I've not used these before. There is no instructions, so we're just going to figure it out based on these images. So it looks like there's a male and a female kind of like metal connector, which are here. And it looks like the female ones go in the male one here, which would make sense, I guess. And then the prongs like sticking out on the inside of the female part. And then these just attach in, and then there's grips. Yeah, we'll figure it out. So I need a 3 for this side. So 3. And I think I want to put the female on this side. So let's start by making these the same length, and that's the data one. Actually, I don't super need that data cable because I've got blue on it, but it's just useful to have. Let's make all of these the same length. How much cable do I want? Give it a bit more than I would think, because then that just means that there's less chance of things getting like pulling on things. So we'll cut all of them to that length. Then strip them down. And if we're going to use the female end here, like I just said, it looks like that means we need to put male end connectors on. So I suspect it's a case of put this over the wire, like that, and then take the male end, which is this one, pop it through there, and then clamp it twice, because there's two, each one of these has like 2 clamps. There's one at the back here that holds onto the actual like plastic sheeting and holds everything in place. And there's another one next to it, which is the one that actually holds the metal. So if we've got that like that, that seems to make sense. Over the rubber, start by clamping the metal. I'm sure there are dedicated tools you can use for this. In fact, my wire cutters here may well have a tool for this, but this way works. And then do the second one over the plastic here. Okay, that seems pretty solid. So that's one male connector put on there. So now I'll just quickly do it for the other 2. Right, so we have all 3. And I'm going to use a female one of these. So what order do I want to have it? I'd like to go the same way as the lights, really. So if we look at the lights, they go, well, it doesn't really matter if it's that way or that way, but it's data in the middle and then power on one side and ground on the other. So data is here, so data is going to go into the middle. I assume that these need to go, yeah, you can see there's a slit there that runs left to right, so these need to go in sideways like that, well, straight on. I'm assuming we'll see it pop out. Yeah, okay, yeah, you can see it's come through the other end. So let's put power on one side. One straight through, okay. So it's just the ground one here, hasn't gone all the way in. And shove them in. And it seems to me that that is good. We've got 3 prongs coming out of there. And then the guess is that when you put the equivalent in the other side, so this is the one that's going to be in the car, I'll just go onto there, and the female bits will be inside alongside those clips. That goes in there, and then, yeah, connection connected. Lovely. So let's do exactly the same on the other side with a 4-clip. And with a 4 gang in place, this thing is basically complete. We could put like a little rubber bung in here to, you know, seal it all off properly, but I don't think it's necessary for where it's going. It's going to live actually inside the boot lid because I want to minimize the amount of wiring that comes from this to the lights. They're notorious that if you use too much cable between the Arduino and the lights, or between the power source and the lights, the resistance drop over the cable will cause the brightness to really drop down. So I'm just trying to minimize that. So this wants to be close to the light, so it's going in the boot. So all we're going to have to do is connect this to the base. As I say, it sits in the base there nicely, and because it's got a slight lip, it won't move about. This channel is for putting a piece of either like paracord or, you know, rubberized band or something with a bit of Velcro on it just to hold this down. I'm not exactly sure how I'm going to do that yet, but I'll conquer that in the final part of this series. Yeah, so that's basically it ready to go in the car and exist, and hopefully that should all be fine. There we go, that's taking one prototype circuit with the Arduino Nano, the Bluetooth, the buttons, all that kind of stuff. I'm fully repackaging it with an ESP-32, the optocoupler and the 12 to 5 volt modulator, and yeah, wiring it all up, putting on these connectors, ready to kind of go in the car. We could just wrap these up as well in some thermal insulation tape. Might well do that after I've finished the wiring, because I don't want to cover up my little notes. So yeah, we'll do that at the very end of the next part of this series. As I said earlier, I did actually record a full breakdown of the code changes between the HM10 and the ESP-32 Bluetooth chips, and the big differences between the two and the way that the code now runs. If I'd put that in this episode, and I'd added in all the 3D modeling steps that we actually did in Fusion 360 to make this box, it would be a over 2-hour episode, and I didn't want it to be that long. So we will make additional videos for those. I expect the coding one is probably going to come out around the same time, probably the same day or the same after this one. So if you're looking for that, just make sure you're subscribed, and it will follow, as will all the 3D modeling stuff in the next few days. Otherwise, we have kind of final steps for this now. It just needs to get installed in the car. I need to get all the wiring from the right location, so from the brake light, from the glow and the switched power into here. We need to wire it from here into the new spoiler, which is sat on the floor, but the spoiler doesn't have the cutout for the light really in it yet, and it's not been wrapped. So there's going to be a little bit of a slowdown on those, but actually getting this into the car we can probably do over the next couple of days. So we'll start with the follow-up video for that, and then the final thing is just going to be seeing it all done. It's going to be the end of many hours of looking at the full steps from, you know, the initial prototyping with all the coding and all of this preparation for car readiness. If you want to see what this actually looks like going into the car and the final result with the big 350Z custom brake light, make sure you hit subscribe, because we've got the rest of it coming really, really soon. And if you enjoyed this video, be sure to give it a thumbs up. You know how to do it by now. Otherwise, whatever you do with the rest of the day, have a wicked one, and I will see you in the next video. Take it easy, peeps. Bye-bye.